Okay, I didn't quite get to finish this in class today, and I really do want you to understand how to do an inclined plane question, all right? So, on the diagram at the right, label the vectors representing the weight of the man, the friction force, etc. Now, the weight is this one, friction force would be this one, and this is the normal reaction force. They are the three forces acting on the guy on the slope. The net force is going to be down because we're accelerating down the slope. Now, so calculate the components of his weight parallel to and perpendicular to the slope. So the weight force is down. And of course, he's 80 kilos, so I can work out the size of that force. It'll be 80 times 9.8. It's 784 newtons. Now I can consider some of that weight force to be down the slope, some of that weight force to be perpendicular to the slope. Alright, so I'll call that part weight parallel and this part weight perpendicular. So on this vector triangle here, same thing, parallel to that, I've got weight parallel and weight perpendicular. So if you like, instead of having a weight force pulling the skier straight down, I could have a force pulling the skier that way and a force pulling the skier that way. So that would be weight perpendicular and that's weight parallel. I could have these two forces, like two ropes around that person, pulling them like that. It's exactly the same as pulling them straight down. So the point is, how can I break those up into those individual components? If this is 20 degrees, that's our hypotenuse of 784. So sine is opposite over hypotenuse. It's a right angle there. Cos is adjacent on hypotenuse. So therefore, W parallel is going to equal 784 times sine 20 degrees, which is giving me 268 newtons. W perpendicular is going to be 784 times cos 20 degrees. 784 times cos of 20 will be 737 newtons. Okay, 2 marks. Next job. Hence state the size of the normal reaction force on him. Well, there is no acceleration in this direction, is there? That means the normal reaction force must be equal and opposite to the component of the weight perpendicular, so it must be 737 newtons. However, the net force acting on the man is going to be parallel to the slope. What I mean by that is this weight parallel, the component of the weight parallel to the slope must be bigger than the force of friction by an amount equal to ma. Alright, so the net force is going to be the component parallel to the slope, 268, less the force of friction of 140. So the sum of the forces parallel is going to be the component down the slope, 268, less the component up the slope, which is friction opposing his motion, of 140, which will be 128 newtons. If he accelerates steadily at this rate from rest, how long will it take him to cover a distance of 200 metres? Okay, well, I haven't worked out the acceleration here yet. Acceleration will be the force over his mass. So I'll get the acceleration as 1.6 ms to the minus 2. Down that accelerates, what are we asking here? The time to cover that distance. So what do I know? Is from rest, so I can use S equals ut plus half at squared quite easily. 200, his initial velocity is 0 plus half times the acceleration times t squared, and 200 divided by 0.8 square roots. I get 15.8 seconds. Okay, make sure you can do this. Make sure you can do this for the test. Sorry, I realised I had that covered up. S is ut plus half a t squared. 200 equals 0 because the initial velocity was 0 plus half times 1.6 on t squared. So t comes out to be 15.8 seconds. You'll need to be able to do that sort of question for Thursday's test. Enjoy.